Well, hello. Today we're going to talk about C factor. C factor in composite restorations, C factor in dentistry. My name's David Alleman. Been practicing dentistry for 44 years. Been teaching a system for adhesive dentistry success for the last 27 years. And one of the main topics that we teach in the 6 lessons approach is lesson 4, which deals with C factor. C factor is explained or defined as the ratio of bonded to unbonded surfaces in a restoration. Why is that important? Well, it was discovered by Carol Davidson and his team, Felser and DeHay, that if you have a large surface area and a small amount of composite, then the composite doesn't have the ability to flow. Well, what's flow? That's another word. Flow is the movement of composite molecules, and the flow of composite molecules movement can be inhibited by cross-linking, meaning if a certain chain is developing in this direction and another chain is developing in another direction, if those chains cross-link, then the developing chains start pulling against each other, and that inhibits flow. So free flow would be an example where the chains are getting longer and longer, but they're all moving and shrinking towards one surface. So that's called one-dimensional flow or uninhibited flow. All of the chains are moving parallel to each other. This is very important to understand in light-cured composite, which 99% of all composites in the world, and maybe 99.9%, are light-cured composites now. In a chemical cure composite, you actually usually have 3 to 4 minutes before the cross-linking happens. Light cure materials, cross-linking happens dramatically, exponentially in that first 30 seconds of the first minute. That means if you have chains of polymers that are increasing, if those chains of polymers are connected to multiple walls that have different directions, meaning you have a buccolingual wall and a floor of the pulpal floor, you would have 3 walls. Each of these hybrid layers now are developing chains, and within that first 30 seconds, the cross-linking is going to inhibit the flow. In other words, the molecules that are happy to go in one direction now have to decide, am I going to go this way, or this way? And so those multiple walls, that's the surface area of the ratio of bonded surfaces to an unbonded surface that can allow a collapse of the polymer. And so you can have a little bit of stress relief by molecules moving towards the center of mass instead of towards one of the hybrid layers. Wow. I mean, that's thinking that you weren't taught to do in dental school. In dental school, you were filling a cavity with 3 walls, 4 walls, 5 walls with amalgam or with a bulk fill composite. But what that bulk fill approach of amalgam and composite doesn't take into consideration is that amalgam can never connect the two side to side, and composite that is bulk filled cannot connect the two side to side and top to bottom. One of those 3 or 4 walls will be weakly bonded, and they will stretch as this massive cross-linking pulls the composite mass towards the center of the mass. So one of the hybrid layer walls will be stretched and weakened or even destroyed in the first 1 to 3 minutes of the bulk-filled material's life. Now, the techniques that were developed to maximize the bond strengths with the light cure, and the light cure hybrid layers were always at least 30% stronger because the hybrid layer is polymerizing in a gooey, flexible, massive, demineralized dentin. And so the strength of that hybrid layer has the ability to be increased if you have more cross-linking in a hybrid layer. So the advantages of using a lot of cross-linking camphor-quinone-mediated reactions in the hybrid layer works really good to make that connection stronger, but it's connecting to a wet, flexible, 20% water, 30% collagen the demineralization of the hydroxyapatite allows the infiltration of these monomers. And the advantage of allowing that that reaction to happen quickly outweigh the advantages of a slower polymerizing composite reaction that is beneficial for composite but not beneficial for the bonding system. But you have to have a compatible bonding system chemistry with your composite chemistry. So you have to make sure that light cure is with light cure or dual cure is with dual cure. All of these different combinations have been tried or mistakenly put together with, if not disastrous results, at least predictable early failure results of large composite restoration. So most dentists around the world will not have confidence in large composite restorations because they have not controlled for the C-factor stresses. And the C-factor stresses have now weakened or even destroyed one or two walls of a 3 or 4 or 5 walled preparation. So a couple of papers that you could look up that bring these concepts into scientific validation. And the one that we like to start with is called Nikolaenko. And that was published in Dental Materials. And that article gives you the ability to say, if I use a layering technique that is horizontally oriented, had the ability to double the bond strength of a 4 millimeter increment, which was horizontal, or 4 increments that were oblique. And so the vertical and the oblique were shown to be able to destroy half the bond strength of a thin horizontal layering technique. So that's your first approach. The next approach to making sure that your hybrid layer has the highest bond strength of 30 megapascals or more is placement of rib-on. And the placement of the rib-on fiber in that first millimeter has been shown in many papers. The early papers that we like to quote are by Sema Belli and her graduate student Don Mez. And then in 2007, the same team did a class 2 experiment with rib-on on the axial walls. Rib-on on the pulpal floor did the same thing as a rib-on axial wall. It redistributed the stress to the hybrid layer. And in both of these situations, they were not able to pull off the adhesive layer, and that adhesive layer with a flowable layer on top of the adhesive layer now becomes a permanent part of restoration. Even if in the experiment you were able to pull off the remaining dentin replacement or the enamel replacement, if you pulled off the restoration, you would always have the immediate dentin sealing secured by a layer of composite resin, flowable composite resin, and the fiber, which would be the separating or the fail-safe characteristic of the restoration. And so those techniques, the one that we mentioned with the before the rib-on was inserted in 2005, 2003, a microfilled flowable showed that same characteristic of a secure bond where you could not pull apart the restoration without leaving a resin coating by using microfilled on top of your immediate dentin sealing. So immediate dentin sealing with resin coating, that is the protocol that gives this secure bond characteristic of a restoration. Adding rib-on into that next millimeter, those are the protocols that we teach in the 6 lessons approach. And if you want to learn more about that, we've made a couple of podcasts. We invite you to watch those. I would really love to have you in our training programs where we go into the details of the science and the techniques so that you know what you're doing, how to do it, and why you should do it that way. Till next time, get bonded, stay bonded.